Welcome back to Chapter 3, Atomic Structure, Section 3C, Isotopes. By the end of this video, you will be able to describe and identify isotopes of elements, recognize the fact that relative atomic masses for some elements are not whole numbers, and calculate the relative atomic mass of an element. Let's discuss first isotopes. What are isotopes exactly? Well, we have said so far that all atoms of the same element will have the same number of protons, and therefore we can use a number of protons in order to identify what element an atom is. However, it is possible for an atom to the same element to have different numbers of neutrons. And how come that is possible? It is possible because in 1932, James Chadwick discovered the concept of neutrons. His discovery explains why some atoms of the same element have different masses. So this is the case here. Atoms that have the same number of protons but different numbers of neutrons, they are called isotopes. Like the example here, we have 3 oxygen atoms and they all belong to the oxygen element. However, if you look here, in the middle of each of these atoms, we have the orange circles which represent the number of protons, and we have the gray circles which represent the neutrons. If we compare the number of protons of the 3 of them, we will find that they all have 8 protons. However, the first one have 8 neutrons, the second have 9 neutrons, and the third have 10 neutrons. Well, they have different number of neutrons, which means they have different atomic numbers. That's why we have in the first one oxygen 16, the second one we call it oxygen 17, and the third one we call it oxygen 18. So these are the isotopes, the atoms that have the same number of protons but different number of neutrons, and of course they belong to the same element. Now let's discuss the second idea in this video, which is the nuclear fission. Understanding neutrons led to the discovery of nuclear energy. By firing neutrons at a uranium isotope, which is U-92-235, it was discovered that a nucleus can be split. When the nucleus split apart, then this is what we call the nuclear fission. And this nuclear fission produces new elements, as you can see here, and of course it transfers large amounts of energy, and this is a nuclear power actually. Nuclear power stations, they use the energy from nuclear fission in order to produce electricity. And an example that represents the nuclear fission reaction is what happened back in 1945 at the end of the Second World War, where 2 atomic bombs were dropped on the Japanese cities of Hiroshima and Nagasaki. The bombs used nuclear fission and destroyed a lot of properties and a lot of humans.